Let's do this, part 2. So, in the last video, I didn't give any problems at the very end, but I just want you to understand that a vector is just a magnitude with a direction, and we can visually represent it as an array of some sort. And we can numerically write it as that, in that form. We know, based on that form, how to find the magnitude and the unit vector. And then, at the very end, we started off about the beginning of a new notation, a new form of a vector based on its components. And we said, hey, if we took our x component of our vector and our y component of our vector, and if we add them, we get back our actual vector. So the sum of our components equal our vector. That's a very cool statement. But this is the length. See, this has no arrow of it. That I'm not. If I don't have the arrow, it's not a vector. This is just the length. But if we took this actual vector, the component, and we scaled it down to its unit vector, the x component at least, you get the standard unit vector I, and that's 1, 0. And if you scale down the y component of the vector to its unit vector, then we get the j, standard unit vector, 0, 1. Now, these standard unit vectors are very useful to identify a new form of vector. And it comes from, hey, well, isn't the x component just my standard unit vector I? My standard unit vector I multiplied by my magnitude of the x component, which is just v sub x. This is the length here. That's v sub x. If we multiply that by I, we're just scaling back to the x component. And then we added, if we multiply the j unit vector by v sub y, we just get the y component of our vector. And remember how I said that if we add the components of our vector, we will get our original vector back. And this is another notation of our vector. We will use these two interchangeably all the time. I will use it in the physics videos, and you'll see it in the science videos, of course. Because vectors are important in describing, if I'm moving at a certain speed, I'm just knowing the scalar, like how fast I'm moving. If I want to know my speed and the direction I'm moving at, then we need the vector. That's why it's useful to understand vectors before you try to do physics. Because so many things in physics are described by vectors. And there's going to be a lot of times we're going to use something called vector functions, vector fields. It is all important stuff. Um, we're almost done. Almost done. One more thing to add on is the unit circle kind of description of a vector. So, if I can actually be here. So, the unit circle is a circle centered at the origin with a radius of 1. Well, what if we took our vector, and this is a unit vector because it's length 1. So if we took V and we saw its components, hey, isn't this a right triangle with angle theta? Isn't this length right here cosine theta? And the vertical length is sine theta. Well, if our unit vector can be described as the sum of our i's and j's, basically what I'm trying to say is this. And maybe the unit circle isn't it's a good description, right? And if you know polar equations and polar coordinates, I think it's better to understand polar coordinates. So let me just put polar equations in there just because for that part. So if you know polar coordinates, you know it's going to be r comma theta, right? And this would just be r sine theta, the y coordinate, and the x coordinate is r cosine theta. That's theta. But if this is a vector, but if that's the vector, we can describe it like this. We can describe this. Wait, what is r in case of this vector? It's just the magnitude of the vector. This is length r, well, that's just the magnitude. And vector v equals the magnitude of the vector times the cosine theta times I plus the magnitude of the vector times the sine of theta plus j. There you go. And the unit vector can be described as just the cosine theta I plus the sine theta j. Now, the reason why that is true is because if we divide both sides by the magnitude, we know that's the definition of the unit vector. But this, it just removes the vectors, the magnitude, from both sides, leaving us with the cosine theta I plus the sine theta j. So these are also some forms to consider. Yeah. But let's do some problems. Because we need problems. Okay. I'm into one. Okay. So this is all the content that you need to know and you need to be able to master. This is all the ideas we have to get. before doing the problems. And this is just a setup. This is just a setup to what we have to know before getting into 3D. It's all set up. So let me erase this real quick. And then pop that off because we don't have to know that. Okay, let's go over some problems. Okay, so before we do the last thing, if I were to give you, well, let's go over one problem. So find vector v given the magnitude equals 2 and theta equals pi over 6. Okay, so what would this be? How would we figure this one out? We would just... why is there a theta in there? Why is there a magnitude? How do we find the vector? Let's just draw a picture first. What is my theta? It's pi over 6. That looks like that approximately. So we know that's pi over 6. And the length there is 2. How do we find the vector? Let's figure this one out. Hey! This is a right triangle. This is vector v, of course. Oh, what is this length? The magnitude of the vector times sine theta. This length right here is the magnitude of the vector times the cosine theta. Wait, this is kind of like polar coordinates, but we're using vectors. So, there you go. So, vector v is just... I'm going to use that notation. It's just twice times the cosine of pi over 6, comma, twice the sine of pi over 6. There you go. And you guys, you have to know your unit circle. It's very important to know the unit circle for these kinds of problems. Otherwise, you can't really do it. So, for instance, if you don't know your unit circle, there's usually this little thing on the back of your textbook that has the unit circle. Just memorize the first quadrant, apply the patterns to all the rest. So, the cosine of pi over 6 is root 3 over 2, which is just root 3, because we multiply by 2, comma, the sine of pi over 6 is just 1/2. Oh, that's just 1. We found our vector. There you go. And we know it has a magnitude of 2. We know it has. We were given the magnitude here, and the angle is pi over 6, and we found our original vector. And there you go. So, how about another problem? And this problem is a little bit harder. And okay, so the next problem, we're gonna have to add vectors numerically. We already know how to do that. So let's see real quick. I gotta find this. Okay, so a vector v equals 2I plus 4j, find theta. So let's draw a picture. How do we represent our vector 2I plus 4j? Well, it's at 2, 4. The terminal point is at 2, 4. So 1, 2, 1, 2, 3, 4. Let's just say it's right there. That's vector v with its components. This is 2I. This is 4j. That's where the vectors come from. Make a right triangle. So now I have to find theta. How do we do that? Well, how do we relate these two quantities or magnitudes? The tangent of theta is your what? Opposite over adjacent. 4 over 2. And theta is the tangent inverse. So the tangent inverse of 2. So, and people memorize this usually, the angle given your vector. We usually say, hey, just the angle of your vector is going to be your tan inverse or arctan. I don't care what you call it. So, it's funny how people have two different names for that. Tan inverse, arctan. It kind of makes sense because you want a different name for an inverse function. But it's even written differently. It's tan inverse. This is how it's written on the calculator. Arctan is another one. I don't know why it's like this. So, it's just a little random. I grew up with tan inverse and not arctan. So, the tan inverse of what? Your y component over your x component. That's your angle right there. That is your angle theta of any vector. Just the tan inverse of the y component over your x component. Let's go over one problem, another problem. Find the unit vector if the actual vector is 6, 7. Okay. So we're not going to really draw something for this one. Okay, remember the formula for a unit vector? It's just the normal vector divided by its magnitude. Well, that's what we're going to do. We're going to find the magnitude. So how do we find the magnitude? the square root of the squares is 5. So we got that, and I'm gonna get my calculator out because I don't like. If I come up with random problems, I'm gonna have some random gibberish answers. So, if we do the square root of 6 squared plus 7 squared, we're going to get the square root of 85. So the magnitude of vector v is the square root of 85. Well, let's just divide that. So the unit vector is 6, 7. Over the square root of 85. And a lot of people, some textbooks, some people really are irritated about this form. So they just go like, hey, this is the square root of 85 over 85 times this. I don't care. I really don't care. Sure. And some people even distribute that, but I don't. So what I did here was I wrote that as 1 over square root of 85 and then rationalized it. So, well, that was easy, right? That was no big deal. Let's see, my battery's critically low. Sorry about that, guys. I'm gonna have to pause the video. It'll end it really soon, but I'm gonna give you some problems. Really quick, so that you can do. You might want to use a calculator for some of these. So let me just write them down as fast as I can. Okay, this one. Number 1. If vector v equals 2, 8, and vector w equals negative 7i plus 4j, then find a vector v plus vector w, vector v minus vector w, 2 vector v plus 3 times vector u. The next problem, similar to the other one, if vector v equals 2, 5, 3, find the angle that it makes with the y or the x-axis. So that's what I'm trying to say. What is that angle? And 3, the last one I'm going to give you is a little bit of a tougher one. Vector v has vector v, find vector v. So my question is, find vector v where, okay, this point right here is 2, 8, and this is 10, 71. So find vector v if that's my terminal point. That's finding the point. And that's all I ask of you. And I'm going to ask you to find you as well. And that's all.